Hi students, today we are going to solve the paper 1 multiple choice question of Cambridge International AS in A level physics subject, and that was conducted in the February-March 2023, and its code is 9702. um, okay, let's move forward. Now this is the formula sheet for the paper, and it should be used inside the formula inside the exam, and all these formulas are related to the physics subject, and there are constants also which be used in the question paper. They are useful. Now the very first question is, what represent a physical quantity? So 3.0 kilogram, 7.0 Newton, and 40%. So the first option, 3.0, it is just a number, so it is not a physical quantity. It does not give a complete sense that what is 3 about, what is talking about 3. Okay, so the second thing is kilogram. Okay, this is the unit, it is the unit of mass, but it is the unit. Okay, now the third option, that is 7 Newton, so this is the magnitude, and this is the unit of that quantity force. So the C option is correct one, and it is a physical quantity. Now the second question is, the relationship between the variables d and t is given by the equation, that is 1 over t equals to b over square root of d plus c, where b and c are constants. So the unit of d is meter square and the unit of t is s. Now we have to find the units of b and c, while we have given the units of d and t. Now we have the equation, that one, and so first of all, put the units of t and d, that will be equal to 1 over this equals to, so when we put d equals to m square, so the square and square root will be cancelled, so we'll get b over m plus c. Okay, now try this first options. Try the option A, that is the unit of b is ms, meter second, and the unit of c is second. So okay, yes, we'll get that equation, this one, that is 1 over s minus c equals to b over m. Now remember that we have to remove this m from the equation. Okay, now try this, the option A, that is the unit of b is ms, unit of b is ms over m, it is equal to 1 over s minus unit of c is s. So meter and meter will cancel each other, so it does not give us a complete sense that 1 over s, you can write that s inverse minus s equals to s. So on the left and right side, both the units are not same, so this is so these are not the units, so this is not a correct option. So now we will try the second option, that is we'll try the second one, that is the unit of b is meter second inverse. So we'll put here 1 over s minus unit of c is second inverse equals to, so unit of b is meter second inverse over meter. Now meter and meter will cancel each other. Now here in this place you can see that 1 over s equals to s inverse plus s inverse, so it means it is 2 s inverse. Now you can write 1 over s is s inverse equals to 2s inverse. So now when you see that uh, on the both sides, on the left side and the right side, the units are equal, so this is the second inverse and this is the second inverse, so it means that the option B is correct. Now when you apply that's option C and D, when you check for these C and D, then you will observe that the left and right side units are not equal. So okay, let me try this one. Let me try the option C, that is 1 over s minus, so in place of unit of c we will put it is s equals to meter inverse second divided by meter. So meter and meter are not cancelling each other, so this is totally different from the other options. So the correct option is option B. Okay, now moving toward the question number 3, that is a hollow cylinder which is open. Okay, dear student, if you have any question, you can ask me. I am there for you. I am here to remove all your confusion, and I'm here to answer all the questions. Okay, now question number 3 is a hollow cylinder which is open at both ends has a radius of 3.0 plus minus zero point 0.1 centimeter. So the radius is, okay, given it, you can write that the radius is 3.0 plus minus zero point 0.1 centimeter and a length of 15.0. So its length is, the length of the cylinder, hollow cylinder, is 15.0 plus minus zero point 0.1 centimeter. Okay, now for example, this is the cylinder. This is the cylinder and it is length L, and the radius of the cylinder is R. It is 3.0 and length of cylinder is 15.0 plus minus 1. Now we have to find it the absolute uncertainty in the surface area of the cylinder. So the surface area, the total surface area of the cylinder is, you know, it is 2 pi r times h, r length. So it is h, height. So here height is length, 2 pi r times length. Now by putting the values, 2 pi multiplied by r, what is r? R is 3.0, and what is L, what is H? H is 15.0. So now we'll get that, we'll get 2 multiplied by pi multiplied by 3 multiplied by 15. So we'll get 282.74, 282.74. Now this is the total surface area of the cylinder, and it is centimeters. So now we have to find the uncertainty in this total surface area. So you know that the uncertainty in total surface area is, that is 2, it is divided by 282.74 or 0.75 equals to uncertainty divided by in r plus uncertainty in the length divided by total length. So I'll get that here it will be, so this step, so the uncertainty in the total surface area will be equal to, so here it is 0.1 divided by 3 plus 0.1 divided by 15 multiplied by 282.7. okay, you can write it. Now what will we get? We'll get the uncertainty in total surface area will be equal to, so if we divide, now let's do the multiplication. 0.1 divided by 3, which will be equal to 0.003. So it is 0.0, it is 0.033, it is 0.033 plus, when we divide 0.1 by 15, we get 0.006. So 0.006, now multiply by 282.74. okay, now so 8.006 to the 0.03, now we'll have it to 8.03 and multiply this factor 0.039 with the 282.74. So we get that 11.21. So it is, so the uncertainty in the total surface area is 11.21. okay, now let's back to the options. So the total surface area of the cylinder was that much, 282.75. so it is 282.75. and what is the uncertainty in it? uncertainty in the final measurement is 11.21. So add when we add you can say that, so the total surface area will be, along with the uncertainty, will be, so 282.75, so it will be plus minus 11.21 centimeter square. So the correct option is option A, that is 280 plus minus 10 into centimeter square. So this is the A is the correct option. Now moving to the next question. A snooker ball of mass 0.20 kg has a collision so that its direction of movement changed by an angle of 90 degree. So it means that, so here it is it is given that the before the collision the ball was moving in this direction. Now here, for example, you can see that here something is, now when this ball reach here at this point something get collide with this thing, and the direction of this ball changed from the horizontal to the vertical. So there, so the angle is here 90 degree. So the angle is 90 degree here with this thing. Now we have to do what? The ball has a speed of 0.40 meter per second before the collision. So before the collision the ball was moving with that much speed, 0.40 meter per second, and a speed of 0.30 meter per second after the collision. Now after the collision, when this ball changed the direction from the horizontal to the vertical, then the speed of the ball becomes 0.30 meter per second. Now the ball has a fixed mass and it is 0.20 kg. Now what is the magnitude of the change in momentum of the snooker ball? So the change in momentum, you know that it is equal to, change in momentum is initial momentum minus final momentum. So it is that much. Now we have to find the, first of all, the initial momentum. So initial momentum, for the initial momentum, is uh, mass multiplied by initial velocity, and it is 0.20 multiplied by 0.40 meter per second. Okay, it is kg. Now we will find that it is a value, initial momentum will be 0.080 kilogram meter per second. Now this is the initial momentum, and what will be the final momentum? Final momentum will be final velocity, and it is 0.0 kilogram multiplied by 0.30 meter per second. So it will be equal to 0.0 3 2s are 6, so it is 0.060 kilogram meter per second. Now put the values of initial momentum and final momentum in that equation, and this equation, so we'll get that it is initial momentum is 0.080 minus, and a final momentum is 0.060. Okay, write the kilogram meter per second. So we'll get the change in momentum will be equal to 0.08 minus 2 will be equal to 0.020 kilogram meter per second. So this will be the answer. Now option A is correct. Okay, 0.020. Moving toward the next question, there is a ball is kicked upwards at an angle of 45 degree to the horizontal ground. After a short flight, the ball returns to the ground. Now the question is that a ball is kicked. Now for example, you can draw the figure of it. That is, a ball is kicked from the horizontal, in an upward direction with an angle of 45 degrees. So for example, here is a ball and it is kicked with a 45-degree angle. So it is kicked with a 45-degree angle, and it makes 45 degree. with the horizontal. Now to the horizontal ground. After a short flight, the ball returns to the ground. So after a short flight, the ball returns to the ground that place. Now it may be assumed that the air resistance is zero. So the air resistance is zero. Now one thing should be noted that the ball will moving with the ball will start motion when we give initial velocity, some initial velocity. Now for example, the initial velocity is vi. Okay, so it may be assumed that air resistance is zero. Now what is never zero during the flight of the ball? So during the whole journey of the ball from here, from this point, from the starting point to the end point, what is the factor or what is the quantity that cannot be zero in the whole journey? The horizontal component of the ball's acceleration, the horizontal component of the ball acceleration. Okay, so this is no, yes, this can be zero. This can be zero. So you know that whenever the ball is moving in upward direction, so the acceleration in upward direction, the acceleration of the acceleration of the ball is the acceleration of the ball is towards gravity. It is towards gravity, and it is always equal to minus g. Okay, now at the maximum height, what is zero? The vertical velocity is the vertical velocity of the ball is zero. While at this point, at maximum before going to the maximum point, let's talk about this point, any other point. So for example, this is the point. So at this point, the ball has two velocities, and the one velocity is the horizontal velocity, and the other velocity is the vertical velocity. So at this point, vertical velocity is vi sine of theta, while the horizontal velocity is vx, it is equal to vi cos of theta. Now if you see at the maximum height, when the ball was at this point, at this maximum height, the vertical velocity is zero. Why? Because the ball does not exceed this point. It means that at the maximum height, the vertical velocity is zero, while the horizontal velocity is still there. Okay, it is still there. So and it is equal to vi cos of theta. So it means that the horizontal component of the ball's velocity cannot be zero during the whole journey. So the vertical component of the ball's momentum can be zero. Why? Because when the velocity is zero, so the momentum will be zero. The vertical component of the ball's velocity. So the vertical component of the ball velocity is also is zero at the maximum height. So the correct option is option D. Moving to the next question.